Takes a minute. All right, we are now live. All right. So were there any questions on anybody struggle with this preparation?
Not once you figure out where to find the information you needed.
Yeah. Computing the Z-score isn't too complicated.
I had a hard time with all of it, so I need help. I couldn't get that normal applet thing to work at all.
Oh, you've got to have that.
Yeah,
I would put in the number and it wouldn't come up like it showed on the assignment, and I couldn't figure out what I was doing wrong.
Do you have it up on your screen right now?
Let me pull it up. I think I bookmarked it. Let me see.
Because I'm getting to that part myself. So yeah, if you don't have the applet, then because a lot of it is you plug in one and then if
it populates
the score or whatever for you, you just have to transfer that number. So that is important.
And it wouldn't work for me. Okay, so I have it pulled up right now.
Okay, first thing you need to make sure that if you have a number to plug in, you plug it in where you need to. So like if you have the Z-score and you're looking for, let me pull mine up. How about that?
Yeah, look at one of those problems that we did that used that one.
What's it doing now? I'm having a hard time getting my screen to split. It keeps going to my Word document of my homework instead of my... Oh, why is it doing that?
Mine's just taken forever to come up. There. Okay, I probably should take it from mine still. I'm just using the one in the book. I probably need to download the applet so that I have it forever and not have to find that page in the book. But one of the things that I noticed that I did wrong at first was I wasn't highlighting the correct section under the curve of the applet. So if you click on like the white section, it'll turn up blue, or a blue section and it'll turn up white.
Okay.
So if you're looking for the, like the 66th percentile, then what is less than the 66th percentile. So then you need to make sure that when you do that, you're highlighting the bottom two portions, not the top portion. And that will calculate a different area in the top square.
So how do I do that? So I've got it pulled up right now, and the whole thing is blue. The whole bell shape is blue.
It says 1, right?
Yeah, it says 1, and both Z-scores are 1 or -1.
Right. So I know that when you do that, the whole area, because it's highlighting the whole thing. So that's the area of 1.
Right.
But if you click on one of the sides, it will take off some of that area.
Okay, so I clicked on the left side, and it says the area is 0.8413, and the Z-score is still 1, and the Z-score is still 1.
Yeah, the Z-score shouldn't change. Because if you're still working with those same parameters, the Z-score will stay the same on both sides, because that references the standard deviation.
Right.
So I went offline. Can you guys tell me what number you're doing?
We're actually just discussing what the applet is and what it does.
Okay, so you haven't gone to a number yet.
No. Yeah.
So my understanding with the applet, honestly, is just that it's a tool that we use, and it helps us once we've calculated the z-score and the whatever. I don't understand the whole entirety of it. I just know that if I plug in the answers in the right spot, it will tell me the other answers.
Mhm.
Okay, so how do I plug it in the right spot? Walk me through a problem.
Let's get down to one where we used one. Do you want to go through the homework?
Sure.
Should we just start at the, we want to start at the top where we want to
Yeah,
start?
and then when we get down to where we used it, we'll discuss it.
That's fine. Yeah.
Okay, well, did we understand, like, so part one, when we went through, because if we all seemed to have a little bit issue finding the information for part one. So the reading assignment, where that was, we had to find the z-score on,
Oh, yeah, it was down in here.
yeah, way down at the bottom.
Okay, so are you guys are you talking about number 1 in part 1?
Yes.
Yes, yes.
So we had to find the batting averages, which was,
Classify them as unusual or not
Yeah.
unusual.
right.
Yeah.
Okay.
So just in my mind to have it straight, because the z-score is a negative 2.088, it's unusual because it's less than how do I guess I don't even know. It has to be between 0 and 2.
Yes, 2 standard deviations on either side.
Oh, on either side. So it's not
Yeah.
0 to 2, but it's 0 to 2 or 0 to a negative 2, but this is more than a negative 2.
Yeah.
Well, with a standard deviation, you're not going to get a negative because, well, I guess kind of.
But the z,
but you counted 2 over either side.
right.
Right?
Yes.
And since it was over 2 away from the median, or the mean. The median, the mean?
Mean. I think from the mean.
I mean,
Yeah, from the center. Uh-huh.
Then it's unusual.
Mhm.
But if it's in between those, so A was unusual because it was over 2 away from the mean. B and C.
It's just 0.19. I don't get that.
So no, because when you have to calculate the z-score first.
Okay, so
that would have made it a negative 2.08, and then which made it unusual because it was more than 2 deviations from the mean.
Okay, so
And you had to find the batting averages.
Yeah. So the first step to solve these problems, the first step was to work through that formula to get the z-score.
So you have to go find the batting averages on the Excel document.
oh, okay.
So it's the same Excel document.
Right. I pulled up the Excel document, but I guess I just was looking at the score. I didn't compute the z-score, so that was where I left a step out. I was just saying, oh, 0.19, not unusual. Okay.
So what z-score did you guys get on that?
On 0.19?
Yes.
2.088.
But it's a negative though. It's a negative.
Okay, because I don't feel like I pulled up the batting average. I just calculated the z-score. So tell me why I needed to pull up the batting average.
So what did you use? So what was your what?
Come up with the information to plug in those numbers.
Didn't it on the homework say A is 0.19?
Yes.
I had to have pulled up the batting, but why? But it didn't tell us.
Did you come up with the 2.08?
Yeah, so I had to have pulled up the batting average, but
right. Yeah.
So, well, on the
it was in the book.
In the homework, it said that there was the batting averages, right? So it talked about, but the batting averages, you had to go clear to the end of the homework to do the first part of the preparation. I mean, the end of the chapter to do the first part of the preparation. It wasn't at the beginning. So the batting averages weren't talked about until the last part.
And that's what took me forever, was like, okay, where am I supposed to find this? So that's what you guys were talking about.
Right. Yeah.
Okay, Sherry, how are you feeling?
Well, I'm still a little lost, but so walk me through the first problem. I'm trying to find where the batting averages are I've got the Excel, but I'm trying to find it in the chapter.
In the homework, it's 4.1. If you go down where it tops about the Q plot, starts the Q plots, there's a blue box that says Excel instructions.
Oh, is that where you found it? Oh, okay.
So yeah,
okay.
so
because I used it under 3.2.2 batting averages.
I think that's what I did too.
Yeah, but it's in
so
there.
I went clear down to there and opened the actual thing and found the average. So I did an extra.
Oh, okay.
Okay, so it's actually on
3.2.2.
Yeah.
Where it talks.
Look in your homework, Sherry, at 3.2.2.
Oh, it is. It's right there. I totally skipped
I've got the blue box. Where's the 3.3.2? I don't get that.
Okay.
So as you go through the reading, each of the different sections is kind of numbered. And
right.
Yeah, and so you'll see 2 point starts. Where's the first one start?
3.3.1 I see, and then it goes to 3.4, calculating percentiles.
Yeah.
Nope.
And then it goes
to
4. What?
It's a subheading in between those. So there's a after the 3.2, converting your Z-score.
Okay.
In there's an applet.
Okay. Okay. Now I see it. Okay. Now okay. So the average. Okay.
So to calculate the Z-score,
we have to take 0.280 minus the 0.019.
So what you do is you go 0.19 minus the 0.261. So, and if you plug it into your calculator, put those in the parentheses, the brackets.
Okay.
Then you divide that. Then you divide that by the 0.034.
Okay.
So the 0.280 is the batting average that they show in the homework. The batting averages that we have are the ones on our paper. So the A, B, C, and D, the 0.19, that's a batting average. So that's
right.
So basically, you plug the
I take the 0.19 minus the 0.261, which is the mean.
Yes. Yes.
And divide it by the 0.034, which is the
standard deviation.
And then I get the Z-score.
Yes. Then you get a Z-score.
Okay. Okay.
And then you'll determine whether it's unusual or not.
Right. Okay. I got that now.
And so if the Z-score is greater than 2 standard deviations away from the mean, then it's unusual.
Okay, and the standard deviation is the 0.034.
Correct.
Yes.
But you really don't have to know that. Once you have a Z-score, if you have the Z-score
tells you
that.
Mm-hmm.
Right, okay.
Because if it's greater than 2 or negative 2, then it's unusual.
Okay.
So the Z-score itself tells you don't have to plot anything on that one.
Okay.
Once you figured out a Z-score.
Great.
Okay, so just one more thing on that to make sure it's clear in my mind. So if it's more than a -2 or more than 2, no matter what that average is, the 0.19, once you figure that Z-score no longer matters, right?
Right. Yeah.
You just look at your Z-score and that's gonna.
Yeah. Yeah.
Okay.
So do we need to go through those answers, or do you think you got it?
I think I've got it. I mean, I'll have to work through them still, but I think I've got how you do it.
Okay, so now the next one, we had to use the applet for that, the probability applet, to answer number 2.
Okay, let's see.
With that same data. So we used the 3.35, because that's the question says, find the probability that a randomly selected professional baseball player will have a batting averages that is greater than 3.35. And that's where I feel the applet
point.
Like my signal to use it is the probability, and then it tells you whether it's greater or lesser. It says probability, so the thought in your mind should maybe be look at the probability applet, because they both are probability.
Okay.
But the 0.335 is actually the answer to what we had in D above. So it's the same number, so you don't have to compute a z-score again, considering we just calculated it for the question above it.
Okay, but if I was going to do it in the applet, how would I do it?
You take that z-score and you plug it in to the applet on, so it's the D, the applet.
It's 2.176.
Correct. And so you plug that in to the applet on the right side z-score.
Okay, let me try it and see what my z-score does, what my applet does.
And put it on the right side because that's a positive number.
Right, okay.
Yeah.
So I'm putting it in right now, 2.176.
And then you need to make sure, since we're looking for something greater than that, you only have the very far right little triangle shaded blue. The rest needs to be white.
Yeah, after the red bars. So only
Okay,
shade,
yeah.
yeah. So from the red bar over, yeah.
So then the area at the top that's 0.0148, is that something I don't have to worry
Yes,
about?
no, you need that. That's the answer.
Oh, that's the answer.
Yes.
Yeah, because that's your probability that that average will be greater than that. He only has a 1.5%
it's very small probability.
probability that that's going to happen.
Okay.
Which my son tells me is quite true. He's like, I could have told you that without the math. He knows his batting averages.
Oh, cute.
That was helpful to have, my 10-year-old explain to me my statistics.
Okay, so the answer for D on 1D was negative, or was 2.176, and that's unusual.
Correct.
But then you said we didn't have to calculate the z-score again. Oh, so that's what we just entered in the applet.
Right, because it's the same exact. You have to find the z-score if we didn't just find it.
Okay, I see. Okay. Okay. I'm with you now, and they rounded it to 0.015. So
yes. Yeah. And I did ask, I don't know if you've read the questions. I did ask because one of the teachers always does 4 decimal points, and the homework says 3.
Right.
And the book says 3. And so when I did it with 3, a couple of the problems I ended up with my 3rd decimal point was off by 1 because I rounded to the 3 and he did not. And she said, don't round till the very end if you can help it, which I understand that, but sometimes you have like infinity numbers afterwards. You're going to have to round. So
So I put the answer 0.0148. Should it have been 0.015 if we're rounding to 3?
That's what it says in the answer key.
That's what it says in the key. And I think when if you get that close, like 0.148, that's your answer. But in the key, it says 0.015. You can assume that you're right because you just looking at it and rounding it, you would have rounded up from 8 to
Right. So, my issue was just since our quizzes and tests are computer graded.
Yeah, those.
And to fill in the blank, if we don't have that exactly what they expect of us, which I did, I missed a problem on my homework because I rounded up.
Yeah.
And I'm going back and I'm like, so yesterday, 2 days ago, I took one of the thing and I missed one of the problems. And I think it's just because I didn't put enough decimal points in there.
So read the instruction in the front because I did the same thing too. I read the instruction and I forgot, I needed to round or you needed to change it to a percent, not a decimal, whatever it says. Be careful that you do exactly what it says or they'll compute it wrong. The answer is probably right, but the computer only calculates it according to its algorithm. So on the test, make sure you do exactly those decimal.
Part of that.
Yeah.
No. If she was grading that, she'd go, oh yeah, she totally got that. But oh well. Now I know.
Right.
Okay, does somebody want to take the number 3? Unless we need to go back to that.
I can do number 3.
Okay.
Provide a brief description of the normal density curve. So the shape is bell shape. It lies on or above the horizontal axis, and the total area under the curve equals 1.
I also put that it's symmetrical.
Yeah.
Okay, the
that
shape
it's
is
called
the symmetrical bell shape.
Yes, and sometimes in our work it will be called the normal density curve. Or, I mean, normal distribution.
Right, I did put that too. It's also called the normal distribution.
Right. Everybody else had that?
Yep.
Okay.
Want me to take 4?
Yeah, sure.
In the following z-score formula, please state what each symbol stands for. So the z equals how many standard deviations away from the mean or the center a certain observation is. X is the observed data point. That's what we're trying to find. Is that right?
Or the observed value.
Observed value. Maybe that's better than data.
Yeah.
I put observation number, but
it's sometimes you'll have that and not another number, so it's not necessarily what you're trying to find. It's a fancy X, not just an algebra X.
Right. Yeah. Yeah. It usually refers to the variable or the unknown. So for the observation. So.
Okay, I don't know, I just call it a U because I don't know what it's called. I don't remember. If I'm sure there's a name.
The mu, MU.
MU.
I just called it an altered Y. It looks kind of like
backwards.
Backwards Y.
The funky looking symbol is the mean of the population. Is it sigma? Is that what the other one's called?
Right.
The standard deviation of the population, or is it just the standard?
Yeah, of the population. Yep.
Population.
Makes us sound so smart to say this.
Doesn't it? Yeah. So I can do number 5. That 68, 95, 99.7 rule has to do with the percentages within that bell curve. So the first one would be what they consider 2/3 of the population falls between that one standard deviation. And that's what the 2/3 is, the 68%. So 68% of that data will fall in between. And then the 95, that's 95 will fall at the second deviation, and then the 99.7. So then the majority of the data falls between the second deviation, and then the rest of it's on your outliers.
Right.
Is this also called, I feel like in the video, the health video, he called it the empirical rule.
Yes, yes.
Yeah, It says that in the chapter too.
Yep.
Okay, I knew I had read it somewhere, and then when I was flipping through, I couldn't find it, and I quit looking. So.
Yes.
Yep. Yeah, when she wrote the people had a hard time understanding that was something that I actually thought, oh, really? That's easy? Go back to questions.
Yeah, they spent a lot of time in Math 108 on that one. So.
Yeah, let's go back to last lessons, lesson 4.
Okay, so ready to move on to part 2?
Yeah.
Okay, so this says the mean, is it my turn? I don't know, I'm just jumping in here. The mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8. So A basically wants you to fill out what the mean is and the standard deviation, and they just told us what the mean was and the standard deviation was. So the mean is 150.8 0.8 and the standard deviation is 8.8.
So the scores would normally distribute between the mean of 150.8 and a standard deviation of 8.8.
Correct.
Okay. What proportion of the people who take the quantitative portion of the GRE will score above 165? So how do you figure that out? You put that in your normal applet?
So then you use the Z-score for that. You need to figure the Z-score.
Okay.
So let me just ask this, and hopefully it'll help Sherry in the meantime as well. So it says, what proportion? So using proportion, we probably know we're going to use the probability applet, but also is proportion, is it always going to refer to the Z-score? Or is that not the case?
Yeah, because I think you're looking for, I think what you're doing is we're saying what proportion is above 165.
Right.
So in order to find that, then you need a Z-score.
Okay.
Yeah, to determine that, where it says what proportion will be above, or if it says what will be below. So I think the Z, when you use the applet, I think it's when you need the percentile too, and then you can get the percentage off that top figure.
So to do this one, I would take 165 minus 150.8 divided by 8.8.
Yes.
Okay, then. Can't quite get my calculator. Okay.
So have you got it?
I'm working on it, but I don't want to slow everyone down, but
that's okay, because I think we have to have the applet so that you can see how it works. Go ahead.
Mm-hmm. Mm-hmm.
1.6136.
Yes.
Yeah.
So now, Sherry, can you tell us how to do the applet?
Yeah.
Okay, so then I go to the applet and I type in the Z-score of on the right side, right?
Uh-huh.
1.16. Let's see, 1.6136. It rounded it already to 1.614, and the
Round it for us on there, yeah.
Yeah, it will sometimes.
0.0533 is the proportion.
The probability percentage, I think, that isn't that what we're.
That's the proportion, because that's the area under the curve.
Okay.
So the proportion is the area under is the proportion.
Okay.
Okay, so then it would be 0.0533.
Correct.
Okay, and that's what it says in the answer key too?
Or rounded it, I think, in the answer key.
Yeah. Yeah, okay. Okay, thank you.
So can anybody tell me, and maybe we'll have some of these I don't remember, but when is it going to be, when would it be in the middle portion of the curve?
If it asks you to find the difference, you can do that with the middle proportion, but a lot of times you could just subtract one from the other and it would also show you the middle proportion.
Mm-hmm.
So I don't remember whether it was this or the homework. I think it was the homework a couple of times, or maybe I just was working through problems. I don't remember now. You had to find the difference between what was the probability that you would have a score in between this and this. And sometimes it'll tell you that. So you have to find both Z-scores and then subtract them.
See, I did it by hand. I mean,
So I didn't ever use the applet for those because I just subtracted them. But honestly, I don't know that that would work because with the applet, because the applet always seems to have the standard deviation is the same. You know what I mean? So
right, I don't think
the Z-score is the same positive and negative every time.
Right, because I think if we were going,
but it should be.
Right, but so if we're trying to find the difference between, sometimes the Z-scores are different. If I know that I think it was in the homework, we have to do an ACT score and a SAT score. So you have to find which student did better. And you have one student's ACT score and one student's SAT score. So that is not this. So I was confused for a second, but that would not, I didn't use the applet at all for that.
Oh, yeah, yeah.
That would be
then
separate.
How do you do that then?
Then I would have just subtracted those two figures out.
I did. You have to find the standard deviation for both of them, and whichever standard deviation is larger, because they're both on the plus side.
Yeah, yeah.
You've done your homework. The larger standard deviation means that she did better than the median than he did, or vice versa.
Okay. Okay.
But you do have to actually work the problems out and to know that. So
Okay,
sorry,
so let's go. No, that's good. Let's go to C.
Okay. If a student's score is the 10th percentile, what would their corresponding Z-score be? Now on this one, I feel like I went straight to the probability applet.
Good.
In the area, put in 0.10. 0.10.
Yes, because that's your 10%.
Okay, and then
the top 10.
It's the top 10 now. If I choose
or the top portion.
Okay, so you have to be sure that you have it in the right, because
or the bottom, sorry, the bottom proportion on that one, because it's the 10th percentile, not the top 10.
Okay, now wait. Let me.
So that's the negative 1.282.
Yes.
Okay, so you've got to go back over that, because I've got the right. It's a negative 1.282.
Right. So you use your applet, and in the area above you put 0.10 because that's the 10%.
If you know the percent, put it up in area. That's kind of what I figured out. If you already have that information, the percent, put that in the area box.
Okay, and that's what I did. But now the Z-score, I mean, that's the Z-score, but the highlighting underneath doesn't mean anything on this one. Is that right?
Right, yeah.
Right,
yeah.
But I just do it every time so that I can make sure that when I need to, I'm doing it, because sometimes it does make it's important. So on that one, like it says, in the 10th percentile. So that means 0 to 10 is what it's talking about. So I make sure I've shaded the bottom left-hand side so that I know that that's the actual percentile that I'm talking about.
And
so how would you get that to shade? In mine, it shades the right.
I clicked on it. You have to shade it yourself with the mouse.
Oh, I see. Okay.
And like I said, it's not going to change a Z-score one way or the other, but that's just so that I'm in practice of doing that, because I'm afraid that in 3 lessons, if I need this and I am not practiced in shading it, or I am not practiced shading it now, then on a quiz, I'll forget. And I may need to shaded.
Okay, so I need help there, because I've got I knew where to put in the percentage and I knew the Z-score, but when you said that it's the 10th percent, it's between, what did you say was between?
Well, just going back a couple lessons, the 10th percentile is basically 10 and everything below it is the whole 10th percentile.
Okay, so looking on this normal probability, how do I know that? How do I know where because it's the lowest percentile? It's the lowest on the curve?
Correct.
What if it had said the 35th percentile?
Then in the area above, you'd put 0.35.
Okay, I'm just going to try 0.35.
Your line moves over, and then it shows you the bottom third is shaded. If you've got the bottom third already shaded, so that's the bottom. Okay. That's the 35th percentile and lower.
So like when we came in and I put in the 10th percentile, my right was shaded.
Yeah.
And it stayed shaded.
Yes. Yeah. And you would have to move it to the left, because that would have been on that curve. So if you're thinking about the grades, on the top end is where the 90th and 100 are. So over to the right side will be where the top percent, and over to the left side will be closer to 0. So yeah,
Okay.
that's just kind of the way I think about it. So when I look at the curve, I'm thinking all the good grades are on the right side and all the not good grades are on the left side.
So
Right.
kind of
And then I just moved my shading over. So I just kind of had to think about it in my mind different.
Okay, so I'm going to split the curve in half, and I like the way that you think of that. So
50%.
the peak on is going to be like 50% on up, 50% on
Yes.
down. Okay,
That's good.
I can think of that in my mind. Thank you.
It's so good to have people to learn from.
Yes. For those of us that
You know
love
that I'm not the only one that sees it that way, Joy.
I have to kind of get tricks in my mind to remember how it works. I
Please.
don't get all of it. And like I said, I don't always think through the story problems the right way either. Sometimes I do it wrong and then I think, oh, wait a minute, I need to do it the other way.
I do too.
Yeah. So what is the quantitative GRE score for a student who scores at the 10th percentile? So then you took the Z-score. Is that what you did? Kristen, did you try to,
This is when they tell you to solve for X.
Yes.
And you have to do all the algebra.
And then you have to flip it, right? So then you took the 8.8 and multiply that by the negative 1.282.
Right.
And then add the 150.8 to that.
Right, because the GRE score that we're looking for is the observed data that we don't have in this question.
So that would be,
we are actually looking for X.
We're looking for X.
X minus 150.8 divided by 8.8?
Equals.
Is that how you do that?
Yes, and in order to do that, you have to have what that equals. And so X minus 150.8 divided by 8.8 equals the Z-score that we found above, because that's how you find the Z-score.
Z-score is a 1.282.
Yes, so you had to use the 10 percentile. We had to use, question C to answer question B again, or D again.
Yes.
Because that's where we found the 10th percentile on both of those.
Yeah.
So since we had the scores of the 10th percentile, we could then put that in. And so if you have negative 1.282 equals X minus 150 divided by 8, in order to do that algebraically, you have to balance them out because you're trying to isolate the X equals everything. So you understand that, how to go through all those?
So then you multiply each side by 8.8. And then what? And then what do you do with the
150.8 to that?
Oh, okay. I get it now.
Because you have to do the same thing to both sides to get X by itself.
Right.
And so the answer that I came up with was 139.518.
139.
0.518.
Yeah, 0.518. Yeah. And you could check to see if that was right by putting the information correctly in the Z-score formula. So you should be able to take the 139.518, subtract the 150.8, and then divide by the 8.8, and it'll take you back to that original Z-score. And so you should know if you got your answer correct by plugging it into
walk me through that again. So I take the 139.518.
Right. Subtract the mu from it, which is your 150.8.
Okay.
Okay. Divide by your standard deviation, which is 8.8.
8.8.
And that should take you back to the Z-score, which was the negative 1 point. And so that way you can check to see if your math was right.
Right. Okay. Good. That's good.
Okay. Yeah. So math. Fun stuff.
Yeah. These good exercises for our brain, right?
Yeah, that's what I keep telling myself.
Yeah.
Okay, somebody want to take number 7? Any questions, though? We're good?
Yeah, I think we're good here, right? So number 7A is just filling in the data from up top in the instructions where it says the Mean speed of hydrogen at room temperature is 1,800, and I don't know what that is, meters per second, with a standard deviation of 600 meters per second. So yeah, I guess that's what it is, meters. Yeah. So the mu is the 1,800, and then in A, the mu is 1,800, the standard deviation is 600. And then we're going to use all that data in the calculations below in B through F.
So we have probability on B, so we need to use the applet. Oh, and they all say probability, so.
Yes.
We first have to find the z-score, right? 2,500 minus 1,800 divided by 600?
Yes. Yes.
And so then you plug in that z-score.
Is 1.16666 1.167?
667.
Yes. Now this is one where you're going to need to shade because you have to have the speed over the 250 meters per second. So you know that is, the mean is 1,800. And so if you're looking for over 2,500, that's over the mean. So that's the top portion of your applet that would need to be shaded.
Right.
So what did you put in for the z-score?
The z-score, I got 1.167 when I worked that out. So 2,500 minus 1,800 divided by 600 is 1.167.
Okay. What I did is I did my work on scratch paper. I think I need to print this up and start doing it on this so I can see my work.
Yeah, I have a separate paper.
Yeah.
So I have a lot of papers, but
yes, a lot of papers.
I think I will start doing that because I got the right answer, but then in my mind, as you guys are talking, I'm like, how did you do that?
Yeah.
Okay.
And so with that, since we're looking for the speed over that,
the probability, right? Okay.
you need to be putting it in on the most far right portion of your applet. Shade that blue. Because if you have others shaded, you'll notice that the area changes.
Area changes.
That's the number you're looking for. So you only want the top portion shaded.
Okay.
And what was your guys' answer on that?
So then I got
0.1216.
Yeah. Yep.
Yep. See, to which I put 0.122 because I just rounded.
Oh yeah. Yeah, I don't know where we're rounding yet. I'd probably go about 4 spaces out, and then you can round if you need to.
Well, on the applet, I feel like you can't, it will let you put in 1.16667, but then it rounds it down.
Will round. Yeah, it will round for you. Yeah.
But sometimes it rounds to the third spot, but the area up there rounded to the 4th spot.
Mm-hmm.
So
right.
Yeah.
So I'm really hoping, I'm hoping that our quizzes and tests are very lenient on that.
Mm-hmm.
Well, in the answer key, it says 0.127.
Right. But that's not, it won't even let us get that because of the way the z-score rounded.
Yeah, that's right. Because the z-score didn't give us more than the four decimal points.
Mm-hmm.
Wait, the answer key said 1 or 0.127?
No, it said 0.1217.
Mm-hmm.
Okay, that's better. I thought you just said 127, and I said, oh well.
Yeah, that would have totally been off.
No, 0.1217. But see, that's not how you get it in the applet.
Right. Yeah.
Right, and with that one, I think for sure, if a quiz marked that wrong, then we'd be able to go back and say,
Yeah,
right.
And I think she's lenient. I don't think she's not a hardcore instructor. I think she'll fix those things if they don't work out right.
Yeah, hopefully.
You're just talking about a rounded decimal point.
Hopefully
right.
that there's not I was really hoping that all of our questions would be multiple choice.
Yeah, for
so that
sure.
I could see what exactly they wanted me to put. But,
Right. Yes.
Yep.
So
Yes.
C.
So this one is just, so this one is the opposite. So what is the probability that a randomly selected particle has a speed that is less than? And I wasn't sure what I was doing with this one, but then I figured out that if you just minus the whole so if 1 minus the 0.1216, you'll come up with the difference, right? Isn't that what we're
Yes.
Or you can just shade your area differently, right?
Just shade the
bottom half, right?
And it doesn't.
Yeah. Just where the one section was shaded blue that was above 2,500 to give us the 0.1216. Then click on that and shade the other side blue, which gives us the 0.8784. Is that right?
Yeah.
That's how I did it.
Yeah.
So this is one where, I mean, I had to play with it. I looked at the answer because I was like, I'm not getting that. But I think that's because, so in the first one, we did everything above the average of 2,500. Now, because of that one red line to the far right, it's everything else under 2,500. So everything else has to be highlighted.
Right.
It's not just the far left.
Correct.
Yes.
So that's where like I said, that's where that making sure I'm clicking the right parts of the
shading, right?
Yes, of the shading.
Even whether I don't need it, I'm trying to train myself to do it.
Right.
Smart.
Yeah.
Okay. Everybody ready for D?
Yes.
Mm-hmm.
So what is the probability that a randomly selected particle has a speed that is less than 1,500, what do we say, meters per second?
Mm-hmm.
And I did not, again, write down the Z-score. I have the answer. Does somebody want to shout out the Z-score?
So you do 1,500 minus 1,800 divided by 600, right?
1,500 minus 800 divided by what? I could have looked.
600.
And you get negative 0.5.
Yeah.
Negative 0.5. So on that, our Z-score, we're going to put it. So now do we have to put it in the negative side because it's a negative?
Yep.
Yeah.
And you still have to put the negative number?
Yes, put the negative. Yep.
So we change that to
less than 1,500 meters. So it's less than, so you shade the far left.
And so does that come up, the answer 0.3085? Okay.
Yeah.
So now here's when we have to do between the numbers.
Yes.
Yes. Yeah. And that was just taking those knowns that you had from the last two problems.
Yeah. So
how would you do that on the applet, or should I just compute it?
I didn't. That's the one I just subtracted.
Yeah.
Okay.
Yeah.
So
Yeah.
Subtract the 0.8784 minus the 0.3085. Less than 2,500. Less than 1,500. I know we've done something like this before, but why does that?
Because then it was looking for the probability between those two knowns. So we figured out the probability of it being less than 25.
I see. Okay.
And then less than 1,500. So between the 25 and the 1,500.
Right.
That's
okay.
What's left over.
Yeah.
So let me make sure again, because I didn't write things down like I should have. So we're subtracting the 0.1216 and the 0.3085.
No.
0.8784.
Okay, where are those? 878.
C and D. The answers to C and D.
Oh, C and D because
we know that if it's less than, if it's over 2,500 meters per second, it doesn't really matter to us. We're actually looking between 25 and 15. So we know that the speed can go up to, for 2,500 miles, it goes up to 8.78 is the probability. And then with the 1,500, it goes up to 0.309. And so you have this is a maximum here, and this is a maximum here, and we need to know what's between them. And so you subtract this one from this one, and you get the in-between answer.
Okay.
Is that making sense?
Yes, yes.
So if you just kind of put it like without a curve, if I put it like I thought of it this way, like sort of just on a straight line, it goes to 1. But I need to know the probability that it's between the 0.878 and, 0.309. If I need to know what's between those two numbers in any given situation, I would just subtract the smaller from the larger, and it will give me the difference.
Okay, so now you're going to see how my brain doesn't work, decimals and percentages and things. How do I remember, how do I know which is the smaller one between a 0.8 and a 0.3?
You can subtract. So if you can't have a negative probability,
right,
like that.
So if I got a negative, I know I picked the wrong one.
Yeah, you would have come up with a negative, subtracting the 3, flipping the numbers and getting the other way. You would have been in the negative.
So which is the greater number here? That's what I guess I'm asking.
Yeah, the 0.8784 minus.
Because it's closer to 1.
Can you think, if you turn it, yes, it's closest to 1.
Yeah.
So 1 is 100%. 1 is all the way over. 1 is as big as you can get on a probability. So a probability has to be between 0 and 1. It can't be a negative number.
Okay.
And I think that was from last week.
Right. Yeah.
A negative number, but still in my brain, I'm like, how do I know what's closer to 1, a 0.8 or a 0.3? And
yeah, when you're looking at sizes and you're thinking in proportion is different than probability. And so that's probably what you're trying to think. And this way you can just look at the actual number and say, oh, well, 87 is almost 100. So it's almost 1. So 87 would be closer to the 1 or the whole than the 85 would be. So then you can subtract it out that way.
I feel like somewhere I had numbers that were like flip-flopped in something else that we were working, but I don't remember. Okay.
Yes. Yeah, okay. I remember that. Yeah.
Yeah, negatives were okay a week ago.
Yeah.
Yeah.
In probabilities, they're not.
And we're supposed to remember this for the exam in a week or so.
Yeah, I'm hoping they give me about 8 hours to take that exam.
Right.
Are you okay on that, Sandra and Sherry?
I'm okay on that. I got that one. I'm trying to figure out the number F.
Okay.
What is the third quartile?
75%.
Right.
The quartiles were 25, then 50.
Right. So 75 of the speeds of hydrogen at room temperature. So how do I?
So the first thing I did was I took the 75%, and since it's a percentage, you plug that into the area of your applet.
Oh, okay.
Anytime that there's a percentage, that's my first go-to thing is to go, that's the area of the applet.
Yep.
Okay. And then I have a z-score of 0.674. Does that give me anything?
0.674.
No, wait. What am I doing wrong? I put in the 75, 0.75.
This is going to be like that problem up there. We're up on D where we flipped it and did it algebraically. Because I think we're looking for X here, right?
Yes, but I can see where Sherry's coming from. So in our area, we put in 0.75, and the z-score that comes up is 0.674.
Yes.
Is that correct?
Oh, that's not what comes up for me.
0.674. I thought that's what you read off to us.
Okay, so if I just put 0.75 in my area in the applet, hit enter. Oh, okay, 0.674. What did I do different? Okay.
It depends on how many. If you have if you have something else in your z-score, mine seems to revert to that first. So I always have to double check and put my area in and enter, and then it will change the z-score a lot of times.
Yeah.
Okay, so my z-score. So then I do this algebraically by.
You take the z-score equals, and then how we're solving for x because we're looking for the speed of the hydrogen at room temperature. So that was the data point that we're looking for. That is actually the x in the equation. So the x minus the mu over the.
Okay, so 6.74 equals x minus 1800
over 600.
Okay.
Yeah.
Okay.
And so to solve for x,
right, 600.
You need to multiply by 600 and add 1800.
Add 1800.
It wouldn't be negative 0.674.
No, the 674 is on the right side because you need all of the 75% of it. So use the number on the right.
So really, we should have, for practice, we should have.
The bottom two.
Go ahead, Christy. What?
Yeah, I stated the bottom two portions of that.
So even though the bottom, even though your middle section does a little bit to the left of the center, you would still highlight the center and the right.
Yeah. Right, because it's the third quartile or the.
Yeah, so it's
quartile. So yeah, and honestly, I don't think that's the shading doesn't matter on this one,
right?
At all.
Well, other than it changes your area if you highlight both of them.
Yes, it
right.
does.
Well, there's that.
Yes.
So, but since the thing is with your z-score, so your median, your mean, would be right down the middle. That would be 50th percentile, the 50th quartile, second quartile, second quartile. So the 75th is more than that. And so that's why you end up shading all that. Because if you're just thinking if it was less than that, if it was the 25th percentile, then your negative z-score would come into play.
Right. Then you'd use your negative.
So the positive is because it's the 75th, not the 25th. That makes sense?
Yes. So then the answer is 2,204.4 meters per second.
Right.
Okay.
Now I liked the Q plots. That was much easier for me.
Really?
I don't know. I look at it and kind of go, that looks a lot like that one. How come that one's normal and that one's not?
I know. It's really weird.
Okay, so help me with that too, please.
Yeah, I'm so technology challenged that I spent like an hour looking for the QQ plots on Excel. I'm like looking all up in the top tabs. I'm like, there are no QQ plots here. My son comes and he's like, there's tabs on the bottom, Mom.
It took me a while.
What did your son say? I missed that. It broke out.
He just found him right off the bat. He sat down and within a minute, he's like, Mom, there's tabs along the bottom. Here's your QQ plots right here.
Oh.
I mean, I was Google searching it. I was going to do it all. Didn't happen. But to me, that's information they should put in. Find the QQ plots in the lower tabs on it.
Right.
On the I see on the other. Okay.
I guess they know we should know that. And I should.
Well, and now we all do, right? So
yeah.
Who needed those 3 hours of time anyway?
Right, exactly. Who needs that?
All right. So what is it? D, C, whatever. The first plot.
Yeah, plot A.
Maybe I don't have plot A. There's plot A. Okay, who's got that one?
So plot A is not normal. So depending on it, really, it's depending on that line and how that, you know, how the data lines up is normal or not normal. So that one isn't normal because it curves around.
And I believe that one is right skewed.
Yeah.
So the normal is what?
The normal, it would follow the pattern of that line that they draw through all the little dots.
Okay, so how do you get that line? That's what I don't understand.
Yeah, I don't know how to build them. I was so lost at the building.
So far, we just look at them and say whether they're normal or not. That's the only thing we've had to do so far.
Okay.
Thank goodness.
Okay, so A is not normal.
Correct. One of the things that Sister Wilkinson gave us a little note, and it said if you need help, look at this thing. And the information in that thing that I watched, it said specifically that we, in beginning statistics, said that we don't use QQ plots to detect outliers, which that's what histograms are for, and box plots. But also it said to determine left or right skewing, do not use a QQ plot, use a histogram. Because then they had examples of two that looked a lot like each other, and he said the only way to tell whether that this is right skewed or left skewed or normal, whether it's skewed one way or the other, is if I put it in a histogram, because one of them was right skewed and the other one was not, though they looked very similar.
Okay, so we should not be determining if they're right skewed or not then.
Yeah, you just need to know if it's a normal.
Just normal. So they said if we need to look at skewing, if we're asked questions about skewing, then to plug that information into a histogram, not a plot.
Okay.
Not a QQ plot. So that's helpful. Yeah.
Okay, so B is also
not normal. Correct. And C, I have normal, even though the bottom is a little under and the top is a little over. But they're just barely over, and there's almost the same number under as over, so they kind of would even each other out. And it really does follow that line all the way through.
Yeah, and they also said in the reading that the bottom ones, the very bottom and the very top ones can be off, that you kind of just count them out.
Yeah.
But doesn't the answer key say C is not normal? And I don't get that.
No, I think it says normal.
The answer key, one of them said it was normal or not normal, and the
teacher was wrong.
Was off. So they were not the same.
Yeah.
Okay, so C is normal.
C is normal, and
yes.
And D is normal.
Yes. And E is not.
And E is not. But it looks like it kind of is. Why is E not normal?
I think that bottom curve.
Because there's the outlier.
Yeah, there's just a little bit of it off. It's not quite as straight. So
yeah, don't worry about the outliers on them. They said, don't worry about outliers. But it is the fact that it is an S curve.
Yeah, more of an S curve. The shape is off
slightly. Okay.
And especially towards the middle where the bulk of it is. Where it is off. So.
Okay.
Even though it looks pretty close.
Yeah.
Like if you move their line a little bit, it would probably be better. So I don't know how the line comes in.
Yeah.
An F.
Okay, then F is normal.
Yeah. Okay, do you think we're ready to take a quiz, or does anybody have any other questions?
Wow, you just totally stopped your brain strength. You're not doing the heavy lifting on some of the technology, but you're surely doing it now.
Right.
Yeah, one of the things that I have found helpful is that I have a running sheet of definitions, a running sheet of symbols and what they mean. And like I have like random like the equations. So I have a it has the how to find the z-score equation is on a thing, and the 60, 95, 97 graph. I've written it out, just a basic one, so that I can look at, so that I have a reference to always go back to.
Mm-hmm.
And I just did that this week after realizing that I'm going to have to go back through pages and pages and pages of notes if I don't understand what mu to the second is or whatever,
Mm-hmm.
Right. Yeah, that's a good idea.
So that has helped me. So that's just a hint. Maybe that will help you guys.
It's a good idea.
Yeah.
So.
All right. So we ready to start the quiz?
At this point,
I'm ready.
The normal applet would be my guess. Oh, mine is slow today.
My computer's like thinking and thinking. It still hasn't even pulled it up.
It does not want to do this.
There we go.
Okay. So, okay. So we will need the applet for this. It also says don't round till your calculations are complete. So we can do the questions 1 and 2. Those are just accountability questions.
Yep.
So again, it'll take me time to probably calculate, so be patient.
Okay. It's all right. It takes me time too.
So question 3, we know. Is that what you said, Joy?
So, question 3, you don't know. Okay, hang on. I was just reading the instructions. So when calculating anything, please remember to round to 3 decimal places unless otherwise specified, but do not round until your calculations are complete. So.
Sorry, I dropped it again. I don't know what the deal is, but it just went away. So I'm pulling it back up. Okay, sorry.
All right, everybody ready?
Yep.
Okay, so on question 3, the total area under a normal distribution curve must be equal to 1. Is that what we're?
Yeah, 1 or 100%, but I think it's just 1.
Is it just 1?
Yeah.
Okay.
Under certain circumstances, a normal distribution curve can drop below the x-axis.
Okay.
False. That's what I think.
Yeah, because it should be above, right? On or above the x.
Yeah, yeah.
Okay.
A normal distribution curve is symmetric. Okay. True?
That would be true.
True. Yeah.
I like the true false.
Yeah, those are nice.
At least you have a 50-50 chance, right?
Yeah.
Okay, here we go.
Use the following image to answer the next 2 questions. Which of the following elements of the figure represents the z-score? Would be C.
Uh-huh. Okay.
Oh,
And
hold on.
7.
Christy better take 7.
Yeah. Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
Okay, so now let us think for a minute. Okay, and I think I've got an answer in my brain.
So we have the z-score down there as 1 already.
Right.
So, well, first, what do you all have an answer in your brain?
No, I don't.
Yes.
I'm blank.
Do you, Joy?
So, yes. Yeah.
Now, greater than 1, is that the question?
Yes.
Yes.
The probability that the z-score will be greater than 1.
Hold on, my computer's gonna die. Okay, greater than 1. I have an answer in my brain.
Okay, so my thought is B.
Yes. Yeah.
What you guys thought or not?
You
Yeah.
cut out. Tell me again.
Did you say B?
I did for a change.
Because the probability is what that is the probability of greater than 1. So we have 1 and we have the line of 1 is the red line is the z-score. And so if it's greater than 1, it's got to be to the right hand side.
It's got to be in D. Mm-hmm. Mm-hmm.
So if you were to shade that in your probability applet, your area is now 0.1587. How does that go with it?
You're
So did you plug all that into the?
So I plugged in a z-score of 1, just the area to the right, the top, the top 25%.
Uh-huh.
And the area became
0.84.
0.1587. 0.1587.
Which that's what my.
Is that?
So maybe it's none of these represents the probability that the z-score will be greater than 1?
So when I put 1 in on the right, on the applet, I get the same exact picture we're looking at. So the probability that it is more than is 0.8413. So it's exactly what we're looking at. It should be B.
And I don't think
okay, so if I shade the whole thing, the area says 1. If I shade just the areas of the mean, it's 0.6827. If I shade the area, so if I'm not sure. Can
I just
go ahead?
I think at this point we're supposed to be using the normal probability applet. I think we're looking at this picture on our screen. And so isn't the probability of it being greater than 1 is the area of B?
Yeah.
Okay.
Yeah. Which would be that 0.8413.
Well, I can do the 0.8413 if I just shade the area that's shaded on the picture on the test, on the quiz.
Yes. So if you shade the left, shade the left side in the center and leave the right open, then then that should give you the right. Isn't that correct?
That's the probability. But then if I shade just the area that's in B, then my area changes at the top to 0.1587. Does that have any significance?
I'm trying to figure between B and that none of them represents the probability that the z-score, because maybe the probability that the z-score will be greater than that.
Oh, so what is the?
Do we have to figure out the z-score, or do we not even need the z-score to figure this out?
The following elements of the figure represent the probability that the z-score will be greater.
So they're talking about A, B, C, or D. Which of those represents that it will be greater than 1?
Which of those would change the z-score to make it greater than 1?
The z-score shouldn't change if you're
not change.
Right. So then it's probably none of these. No, if you change A, B, or C, it's not going to change the Z-score at all.
No. It will change the percentage of what is over the deviations.
Yeah,
it changes percentage in the area.
Yeah.
But it doesn't change. It wouldn't change the Z-scores.
So I think it's none of these.
Yeah.
I'm still leaning towards B. Is everybody else feeling none of these?
I need to go back and I don't know. Like now I'm not sure, so I'm okay. So when we did questions in our preparation, we can totally go back and use,
Yeah, we can use notes, yeah.
All of our notes or whatever. Yeah. So when we were asked what is the probability that a selected particle has a specific speed, we needed the Z-score to plug into the probability applet.
Right.
Yes.
But I guess the wording is confusing my brain.
Well, just going by what we do on the applet, I don't think you would change the Z-score at all. But if you were, because we don't know what, well, I guess we kind of know what the mean is. Well,
I don't. Okay.
So let's go back to 6 for just a second. That says, well, that one's just set. I was going to say, which of the following elements of the figure represents the Z-score? Well, we know that that is section 8. And I don't know. I don't want to mislead you guys because to me, it's asking the same thing, but it's asking which of the following elements of the figure represents the probability that the Z-score will be greater than 1. Yeah, I don't know.
So what did we put in for question 6?
We put in the Z-score was what?
C is where the Z-score, what element represents the Z-score, and it's C. Pointing right to the Z-score.
Right, because pointing right to the Z-score. And then
he represents
right. So which of the following elements represents? Okay, which of the following, and so in 7, which of the following elements represents the probability that the Z-score will be greater? Okay, so what we're looking at, we're supposed to just be looking at this image. Okay, so what we're looking at in A is the third quartile information. We're looking at 75% of that.
Right.
That's not going to change the Z-score. It's not going to make it greater.
Right.
Okay. Look, the information in B wouldn't change the Z-score.
Right. It would change the area, but it wouldn't change.
Yes, it will change the percentile that's in the top 25, or it would change that.
Right.
Okay, and it's not going to change
C. The probability?
Yeah, it would change the probability, but it won't change C because that's a static. Right. So I'm thinking on 7 that none of these represent the probability that the Z-score will be greater. Now, the percentage of, so that area, that figure up here in area, it's not even highlighted. So it's not even asking us for for that element at all.
Right.
That's my thought.
Okay, so just looking at it.
I feel like I don't want to lead you guys.
I know, but looking at it logically, would you say that none of these elements represent the probability?
No. Well, no, because A, like you said, A is the area that's the 75% quartile. B is the 25% core, you know, the Q3 and above. A is the Q3 and below, and C is the Z-score. So there's no other element that could affect the Z-score.
Right.
So it has to be none of these.
None of these. Yeah, that's what I'm thinking. It's
where I'm leaning to.
Yeah.
All right, that doesn't make sense to me, but okay.
Yeah.
Well, my only other thing to do is to work that whole problem out, you know, and seeing if I don't know.
But we don't have enough of the information.
So
yeah, we don't.
Right.
Yeah.
No
I'm
way.
sure I'm reading the problem wrong or different, but explain, go through that one more time. I see. So A represents the third quartile. And
A represents 75% of that data. So 75% of the population is represented by A. So
okay.
it's represented by the first quartile, the 50%.
Yes.
Yes. So then together that represents 75% of the data.
Okay. At first I'm going, how does that represent 75%? But if you look at the thing, half of it is 50 and then it doesn't.
Yes. Yeah. It's a pretty even distribution just looking at that.
Okay. All right.
So, and B does represent the upper 25%, but it's not going to change any of the information. And the question is asking what would make it greater than that, the Z-score greater? Well, we'd need different data to make the Z-score greater, wouldn't we?
Probably, yes. Yeah. So, and I'm just looking at it and not solving it. I'm looking at, well, B represents.
Yeah, just looking at what the picture is telling you.
But B is highlighted, so we're saying we don't have that information.
Right. Right.
Okay. Well, even if we highlight B,
we do have information of.
Yeah.
We do have that because it's 1 minus the 84.8413. So we have that information.
One minus the 84.
Because the whole thing is 1. If everything was blue, the area would equal 1.
Right.
Right.
So the B portion is 1 minus the area that's shaded, which is 0.8413.
Right.
So technically we have that information, but that
doesn't change the Z-score. If you
change the Z-score,
area.
Because if you put all that information in the applet and then just shade the right side, you'll get that percentage above
0.15 something.
But it won't change the Z-score.
The Z-score stays 1.
Yes.
Right.
Stays 1.
Yeah.
Okay. Okay. All right. 8.
Question 8.
According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percentage such as 42 rather than a proportion such as 0.42. Okay, so let's think. I've got to think slowly. So we're using the mean minus, is that right?
It's written right in the question.
Yeah.
What percentage is within 1 standard deviation?
So
like 68, is that what it's asking?
Yeah, yeah.
Yeah.
Oh, see, I was going to try to solve to get.
Yeah, no, that was just a basic. And just write 68, right? Don't put any 0 decimals or,
Right, so that's the percentage is 68.
Yeah.
Right.
The normal probability applet to answer this question.
What proportion of the Z-scores will be between -1 and 1? And that's the area and the probability. If you do -1 and 1, it's the blue shaded area.
Isn't that what we've got in here?
We have to, so
we're putting put -1 on the left side, put 1 on the right side in the z-score, correct?
Right.
And then what are we shading? So then
you're shading the 68%.
So shade the 68%.
You're shading what will be between a -1 and 1. So
and
just the middle.
Yeah.
Yeah.
So
the answer is 0.6827. Is that what everybody got?
Yeah. 3 decimal points.
And I guess when I read that, I realize that it says to use that, but if the z-scores are between -1 and 1, and those are the standard deviations, then wouldn't it just be like, in my mind, I just think we'll just go back to the 68% that was in the last question, because those are one standard deviation away. So that's the percentage that's in between.
So are they wanting us to put 0.683, 0.68?
Well, see what it says? It says accurate to 3 decimal places. If the answer was 0.389184, you would enter 0.389. But so 1's not going to round up.
But yeah, and
but it doesn't say round it. So I don't know if that's 0.68.
That's 0.683.
Yeah, that's what I would think.
I think you're right on, Christy, because if you took away the 3, you're at 68% again.
Right. And so, just without using the applet, I could answer that question pretty close, just because it's one standard deviation away, and that should be 68%.
Right. I think they just wanted us to get that extra decimal place in there.
Or to use the applet.
Use the applet to kind of practice all this. Yeah.
Okay, so then what proportion?
All right, who's got 10?
Okay, so suppose that the z-score came from a standard normal distribution. Use the applet to answer the question. What proportion of the z-scores will be between -2 and 2, and give your answer as a decimal accurate to 3 decimal places? So plugging in a -2 on the left side, a +2 on the right side, we're looking at 0.955.
That's what I think.
Yep.
Okay. All right. And just change this to 3.
Everybody, let's see. So does everybody have question 11?
Yes.
Yep. First of all, are you guys putting a 0 before? Are you going like 0.997?
I do a 0 before.
Probably because in question 9, that's what the example is showing. So I wasn't, but I am now.
Yeah, I didn't either, but now I guess I better.
Okay, so on question 11, did everybody get 0.997?
Yes.
Right.
Yes.
12, look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 99.7.
Yep, that's true.
Yep.
That's it.
Is that the only one? Did you guys read it already?
Yeah. Well, the other 2 aren't correct because they don't double, and the z-scores area in between them doesn't decrease, it increases because getting more and more percentage of the probability.
Okay.
Oh, I don't know that I like this next one. Too many
Oh,
words.
there's too many. Oh, this one looks ugly. This one. My daughter likes to say this one looks like hate.
Hate?
Like I hate this. It looks like hate. I hate this.
Algebraically, the dot means multiply.
Yes.
What makes multiply?
The circle, the filled in round dot in the middle. Right? Because they can't do an X because then we
the black dot looks like usually they use a star. So I don't know why. Yeah,
I think it looks kind of like an asterisk.
Asterisk. Yeah. The asterisk, yeah.
Okay.
Somebody want to read it?
The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. So gram protein times kilograms.
Oh, wow.
The negative power?
-1.
So -1 times the
Weight.
Each day to the -1?
Each day to the -1? Oh my goodness, that's quite the equation.
The population mean protein requirements for adults is 0.65 grams of protein times kilograms of weight to the -1. And the population standard deviation is 0.07.
Oh, heavens have mercy. Oh my goodness. Okay, so let's see.
I don't think we have to worry about doing the -1. I think we just still have to figure out. Can we still do it with the 65 protein requirement and the standard deviation? So the mean is 0.65 and the standard deviation is 0.07.
Right.
0.6.
Before we freak out,
what proportion of the population have a protein requirement that is less than 0.60?
Okay. So if you're going to do 0.60 minus, so we're going to get a z-score here for this?
Yeah. 0.60 minus
0.65 divided by 0.07.
Okay, what is our x?
0.60.
0.60 minus 0.65 divided by 0.07 gives us our z-score, right?
Yes, divided by 0.7 gives us the z-score of -0.07, right?
Negative what?
-0.7142. I don't know how far over we're going. 3 decimal places. 0.14. So
I lost my calculator. Hang on, let me.
0.714.
Uh-huh.
Negative.
Uh-huh.
0.06 minus
protein. That is less.
So has everybody moved on except for me?
No, so I got the z-score of 0.714, and I can put that into the applet, right?
Mm-hmm.
Uh-huh.
Negative 0.714.
And now this is?
Less than that.
So it's only going to be everything to
on the left side of it.
Just the left side, not the middle, right?
Right, not the, yeah. So just that 20, just the first quartile. 0.238, is that what we're putting in there?
Mm-hmm.
Okay, so I have to remember to work the whole way through. The answer is not the z-score because we are looking at the proportion, which is the probability. So did everybody get 0.235 then?
0.238.
0.2376 and round it up to 0.238.
I'm rounding the 7.
Yeah.
0.238.
Uh-huh.
Okay.
Is more than that. So you just shade the other area. Oh, let's see how we're figuring this out.
So just to review, what have you got for 13 then on this one, this first one? That's where you have the negative 0.714, correct, on 13?
Right. It's the z-score, and then you put that in.
No, the answer.
And then on 14, we have the 0.2.
No, on 13, the z-score isn't it. You have to plug the z-score in.
Into the applet, and then you get the 0.238.
Uh-huh.
So 238 is the answer to 13.
Uh-huh.
No, wait a minute.
Yeah, less than 6.60.
Okay.
Okay, Sandra, what are you stuck on?
We're okay on 12. Okay, 13. So we have to go clear through the whole thing and use the normal probability on applet on question 13, right?
Yes.
Right.
So we calculated the z-score, which was a negative 0.714.
Right.
Okay, we put that into the applet. So the proportion less than 60% was 0.238.
Right.
Okay, then I'm good.
Okay.
Okay, so 13 isn't, so 13 we need to use the applet and get a percentage, right? Is that what you're saying?
Right.
Yeah.
Get the area or probability or proportion. All of those things translate to the area on the applet. Area, population, area, proportion or percentage.
So
again,
probability.
Okay, so I guess I'm confused. I guess I was looking just for the z-score here on 13. So on 13,
that's what I did at first, Joy, is I just found the z-score, but it's not asking for the z.
Yeah, it says what proportion, which is also the same as percentage.
Okay. So,
which is the same as the area of the probability applet.
okay,
right.
So plug that in. And then when you're looking for less than 6, okay, hang on.
Yeah, so you shade that area. I still don't get why you shade.
I'm not getting this one.
Quartile. Why do you shade only the first quartile to get your area?
You are.
Okay, because it's the mean protein requirements is 0.65. So it's a negative. So the z-score you got was a negative z-score.
Right.
So that means it's got to be on the left side of the mean. And so the proportion of the population to have the protein requirement less than 60 has got to be less than is on the left-hand side.
Because it's more than one.
Okay. And so that should be less than. So that should be the 238 then.
Correct.
Okay. So 0.238.
So the next question where it says is more than 60. We found the z-score for the 60 grams already, so you just would shade the other sides of that.
So that's the same thing, right? It's the same. So if you shade the right side,
I think that you Or you can subtract that from 1. And you should get the same answer.
So those two answers are the same.
No. You have to shade.
1 is less than and 1 is more than.
Percent. Everything over the 60%. So that's everything else other than what we had highlighted last time.
Okay, so I'm still lost. Okay, so the answer for 13 is 0.238.
Correct.
Okay.
That's what I think is correct. I don't want to tell you that I'm 100%. Yeah.
Okay, and then the answer for 14 is also that same thing, because you're just looking at the top portion of the more than, or are we looking?
You use the same, I've used the same thing. The only thing I did different was I shaded the other 2 portions and made the first portion white.
Okay, so then the top 75% needs to be, leave the bottom quartile empty and shade the middle section and the right side.
Right.
Okay, so then that will give us 0.762.
And is everybody else on the same page as I am?
Right, but you could get that 0.762 by subtracting 1 minus
1 from
238.
Yes.
Right.
Yeah. Yeah.
You guys were cutting out, and so you can get it from subtracting 1 minus what?
The answer from number 13.
Yeah, because your whole distribution is 1, and so then if you take the 1 minus 0.238, you would get the 0.762.
Right. I was just also trying to make sure that I was shading that applet right, so that when I was looking for those kind of questions, I would that, kind of a double check kind of thing.
All right, is everybody ready to go on to 15?
Yes.
What proportion of the population have a protein requirement that is less than 0.70 grams? So now we have to resolve the Z, right?
No, how do you do that? You do the 0.70 minus the 0.65 divided by 0.07.
Yeah.
And it should be just the positive side of the other, because it's 0.5.
That's right. It's a positive Z-score of 714.
Yeah, because it's the same amount above as the last one was below the mean of 0.65.
Explain that to me first.
So 0.65 is the mean.
Okay, what one are you looking at? 0.65?
Both of them. It doesn't matter. It's all the same information from the big question. Yes. The mean was 0.65 grams.
Okay.
And so the first one we did was the population requirement that was less than 0.60 grams. So it was 0.5 gram or 0.05 grams less than. And but 70, 0.5 above. So it should be exactly the opposite because of the other one, because it's the same difference from the mean. 0.05 below is the 0.60 and 0.05 above is the 0.70. So that's how I've checked to make sure that my Z-score is correct, is because they're the exact same from 0.
Oh, do you have different numbers? And so on then 13, are you less than 0.6? Do we have different numbers from each other? Because now we're looking at 0.70. So on question 15.
But it's this. We have the same mean as 0.65.
Okay. Okay.
Because it all came from that first original paragraph.
Sure. Right.
And so what
the Z-score would be the same. It's just on the positive side.
That's how I've checked to make sure my Z-score was correct.
So the answer in 13 and the answer in 15 are the same answer. You still have 0.238 because it'll be the same deviation on both sides then, correct? Even though we're looking at the...
Yes, because we're looking, does it say below or above?
Well, this is less than, hang on a second.
No, it won't be because there's
less than
more.
0.7. So you're going to have everything below, which would be from the third quartile below, right?
So just your Z-score for right now is how I double checked that. I'm not trying to confuse you. I was trying to, hopefully I was helping you figure out to make sure that midway through you could check your math.
Oh, okay. So I'm still lost then. Okay. So hang.
Okay, but what was your Z-score from that?
Okay. So when you calculate the 0.70 minus the 0.65 and divide that by 0.07, you get 0.7142.
Right.
So you get the positive. You get the positive side of.
Right.
And that's as far as I was saying to check your math there before you plug anything in.
Okay.
Does that make sense?
Yeah. So okay.
So now if you're plugging that into the applet, but you're looking for everything below this or the bottom. So it says less than
70, right?
So am I putting 70% up in the area? 0.7?
No, you're putting your Z-score in.
Just put the Z-score in. Okay. Okay, so basically the same Z-scores there that we've been working with. Okay.
Right.
But just so that I'm on the same page, because it's less than the 70 grams, I'm highlighting the far left only.
And the middle, right?
And the middle.
In the
So
middle.
it's the same 0.76.
0.762.
Less than 70. Oh, okay, so because less than 70.
That's the answer that's the same, because that's what I was missing. I needed the middle section too.
That's what
I need the bottom half. Okay.
So 70.
What's above the 0.6 is 7 points. Yeah.
Yeah.
What's more than 0.60 is the same as what's less than 0.70.
Yes.
Only shifted differently.
Shifted differently.
And I mean, we all got the same answer, right? But that's 0.762.
Yeah, 0.762. Okay.
And 14 was 0.762.
Uh-huh.
Right.
Right. Okay.
0.762.
0.762. 0.7.
Yeah.
Yes. Okay.
Okay.
And, okay. Sorry about that.
That's all right. Like I said, this is the way I'm understanding it. So.
Yeah. Well, I like the way you understand it.
Yeah.
Well, I'm hoping it's right.
Help me understand it. Yeah, right.
Yeah.
There's pressure. Because if we get it wrong, I'm going to feel horrible.
Well, we'll know. We can submit it, and then we have another attempt.
Yeah,
So.
just redo it.
Okay, so to question 16.
62 minus the 2.38. So we're just going to take those two values now, right? We're going to take the 0.762 and subtract the 0.238. Is that right? The value between.
That's what I think is right. Anybody else?
So has everybody got that answer?
For 16, so we just subtract.
It's telling us to shade things in their thing.
Remember that to find the area between two values, shade to the left of each Z-score you calculate.
Yeah, that's right. That would be right then. 2.5 though, if it's rounds it.
Okay, so
5.25.
0.7624 minus 0.238.
Okay.
So now we're only looking in the middle because we're looking for the difference from the top 75% and the bottom 75%. So you're taking the 7.762, subtract the 0.238. So that's really just the middle. That's just the 68th percentile if you're looking at the
right, but it's the 0.5248 is the probability, right?
Yeah. And round to 525, I guess, because if we're going to round it.
0.525.
Yeah.
That was what I got for my math too.
I mean, I got it by subtracting, but I'm not following what it's saying to highlight. It says, remember that to find the area between two values, shade to the left of each z-score.
So that would be just the center. So just have the very center of the bell curve shaded, nothing on the right or the left of the red bars.
If it says, okay, am I not reading it right? I mean,
you're reading it right, because what it's telling you to do is to shade everything to the left of both of them to give you the probability, and then it's telling you to subtract the numbers and not use the applet necessarily to do the subtraction.
Yeah.
Subtract the smaller area from the larger area.
Which I don't know whether it's in all cases, but in this case for sure it is. If you just shaded the middle portion, it's the same thing.
Yeah. Yeah.
Okay. All right. Whatever.
That's what I say too. Okay, whatever. Is that? Okay, find the 35th percentile.
So the answer is 0.525.
Yeah.
Okay, so to do the 35th percentile, you go to the area. Correct?
Go to the area and put 0.35 in there, right? And what are we looking for? 4 point.
Does everybody have it?
Was it just the 0.454?
No, I think we need to plug it into the applet then to get this z-score and then work it out algebraically, don't we?
Find the 35th percentile of protein.
So that gives us the z-score, which then because what we're looking for is we're trying to solve for x.
Is that what we're looking for here is x?
The 35th percentile. Third quartile.
Okay.
Okay, so where is the other information coming from? So we have the 0.454 equals x minus.
Okay, so
where are you getting 0.454?
That's the z-score.
That's the z-score.
So if you put 35 in the area, I put 35 in the
blue area, and then my z-score is.
Okay, I blinked out a minute. My internet was down.
What did you get, Christy?
I have 0.35 in my applet, and I have negative 385 in my z-score.
Negative what?
385.
I have negative 4.5. Okay.
Mine is just 454.
Right. 454 negative and 454 positive.
Yeah. Yeah.
And your normal probability applet?
Yeah.
In your area, I have 0.35.
In the area.
In the area. 0.35 in the area.
And my score is not that.
And so what?
My z-score shows negative 0.385.
Oh, wow. I don't have.
What about your shaded area? Change your shaded area. Leave it all blank. No, that doesn't change it, does it?
No, you got to keep the 0.35 up top.
Why is it not doing anything?
No, refresh your page. Maybe I'm going to refresh my page and see if that helps.
Okay.
Okay, 0.35, enter.
Yeah, so that gives you 0.454.
Oh my gosh, mine just changed to 0.935.
That's what mine did too. But
What did
before
it change to?
4.54.
And now it's 0.935? Or no?
Yeah.
How come it's not the same? This is the first time all points 0.35 in my area. Okay. Now
Mine's not working either. But I did have the 4.54.
Does it say something different now?
I just refreshed it and it had some different scores in it. So let me try it again. 0.35.
So I refreshed mine and now it says
Got mine too. So now I have 0.935.
that's what mine says.
Okay, so then if you take the 0.7.
It's not saying that. Let me.
Okay, I'm really confused.
Okay. 0.07. Multiply that by 0.935. And then add 0.65 to that.
Okay, so I am still way back.
0.7.
So do you have the applet up?
So I think I finally got, yeah, so mine finally got refreshed. So Z is the 0.935, right?
Yes. Yeah.
And then it's the X minus, we're still working with the 0.65?
Yes.
I'm lost too.
0.07. Okay, where are you at, Sherry?
I don't know.
Okay.
So I got 16, then 17. So if if the Z score is okay.
Okay, so
In your area, did you put the percentage of 0.35?
Okay, so then I'm going to change that area to 0.35.
And what do you get?
4.454 Z score.
Refresh your page.
Yeah.
Refresh it.
Yeah.
Yeah.
You should get a Z score of 0.935 now.
but did you see I just did it again and now I'm back to 0.385.
Now you got another one?
I did. But do you only have one side of your group of your thing shaded or is it two?
Oh, that's the
it's
problem.
two.
The first side.
Oh. So see, that's
The 35th percentile is shaded, not all of it, just the first part.
So now you have, okay, so now we have a negative 0.385.
Yeah, that's what I have.
Okay.
Maybe.
Oh my heavens. This is, how would we even know?
I don't get this either.
Okay, so it's asking for the 35th percentile for the protein requirement for adults. So the 35th percentile is less than the median.
Right.
So that's how I choose to do just the first quartile.
Okay.
so
it's not really a quartile, just the first
yes.
section is shaded.
Okay,
because
so
if you were to draw that imaginary line right down the middle, that would be 50%. That would be your mean if it were 50%. So we're only looking for the 35th percentile, which is less than the 50th percentile. So that's why the right is shaded.
Yes. So the area above the 35%, the first 35%, the smallest 35% of our whole applet is shaded right now.
The left side.
That's what that's showing.
The left
side is shaded. And that is technically, even though it may or may not look like it, that's 35% of the area of the whole.
Of all of that population, which is
of the whole
of the whole thing. Okay.
Oh my gosh, you guys, I'm sorry.
Okay. So to work that, did you work that math out, Kristen? Did you get 0.623 then?
I haven't worked it out yet.
Okay.
Because do we all have the Z score?
I have the Z score, but what to mark is still throwing me for a loop.
Okay, so when it's asking for the 35th percentile, so that means everything, so if you have 100% of something, up to the 35th percentile is 0% to 35th percentile. So 0 to 35.
So that has to be on the left.
It does have to be on the left. Well, and because if it says 75th percentile or greater, that's on the right.
Yeah.
When you say it, it makes sense. And then when I go to put it in, it doesn't.
So when we put in the area as 35%, and then we shade that bottom 35th percent, the z-score I have is negative 0.385.
And we have to use the negative because it's on the left-hand side.
Yeah.
Yes.
Okay.
And
I need some help here because my internet went down and I missed the last couple minutes. So tell me. So I put in the 35 percentile and I got the z-score of 4.454.
Okay, so I don't know where you're getting that one.
Okay. So let's go back to where I had it as negative 0.714 when I was computing the other ones, right?
Yeah. I honestly don't know why, because every other time we've all plugged it in, we've gotten the same answer. This is
really throwing me this problem. I think we should.
Okay, so now I'm back where I was when we were computing below 0.70 grams of protein, and I have the 0.7624, right?
Okay.
in my area. Okay, so now I'm going to change the 0.7624 to 0.35, right?
Yes.
In my area. Okay, so I'm going to 0.35 and I hit enter. Oh, there it is. Negative. What did I do wrong then? Okay, 0.385.
Correct. But is only the left side shaded?
Yes, that must be what I had wrong because it was shaded differently before. Okay, so that's the answer then for find the 35th percentile?
No, that's just the z-score.
Okay, the z-score.
So the 35th, the 35th percentile, we're going to have to work it out algebraically to find the x, like we've done it before. So I have negative 3.85 equals x minus 0.65 divided by 0.07.
Okay, let me.
Is that what everybody else is understanding this question means?
This question is throwing me. I'm not sure what you're.
Okay.
Yeah. I'm not sure what the steps are for solving it, but I'm with you right so far.
So I went to our homework and found a question that resembled this.
Okay.
Or not our homework, our preparation. And so if we went to 7F, where it says, what is the third quartile of the speeds of the hydrogen at room temperature?
Okay. All right. You're so smart. Thank you for helping us sort this out.
Do that where we solve for x. So
solve for x. Okay, so I did that. Did you get 0.623 then?
I haven't actually solved for x, but I'll do that right now.
I don't know what the x what's the mu? 0.65?
Yeah, same as before.
Yeah.
Okay. Okay.
You okay, Sandra?
Yeah, I have an answer. I got the same as Joy, but my question is, how do you put this into your calculator as you're working it? Would you first of all take a negative 0.385 times 0.07 and get that answer before you add
So
this?
you know what I do? There's a shortcut to doing this so you don't have to do it algebraically. So you just do the problem, work it backwards. You take the 0.07, multiply that by the negative 0.385, which is by the z, right. And then divide that by your, okay, hang on just a second. That's not the way I do. Then subtract your mean from that. And then that should give you your answer.
Subtract, you don't add it?
Yeah, no,
you add it, don't you?
You add it.
Oh, right. Sorry.
Okay, so
Yes, add it. Sorry, my bad.
on the calculator, I'm going to type in a negative 0.385 times 0.07, and that comes to a negative 0.02695. And then to that, I'm going to add 0.65.
Right.
You know what? I just put it all in. Just put it all in one notation. So
but that's fine. You can do it that way, Sandra.
Yeah.
You multiply it by the 0.07, the negative 385, the negative 0.3, and then you add the 0.65, and you should get
0.62305. So 6.
Right.
Yeah. Yes.
That's what I got. And I actually do it. I don't know how your calculators are set up, but I do it in the 2 steps. So I multiply it by, and then
so
I
you do it algebraically first.
I don't use the parentheses because I want to see my steps, and my calculator actually shows me the steps I've taken.
Oh, okay.
So once I get the answer, then I just add the other, and it'll say answer plus 0.65.
Oh, okay.
So you did it like I did it then, Christy? Is that what you're saying?
Yeah. I do it step by step because I want to make sure that
Is there any way that you could take some shots of that and email that to me so I can see how you're doing it? Because I don't know if my shortcut always works, but it's how someone showed me how to do it that way. And
I don't know if you can see that, but that's really all I do is I just do it in 2 separate steps.
Okay.
So I just take minus 0.385 times 0.07, and I get the answer.
Minus 0.385, and then you multiply that times 0.07.
And I get an answer.
Okay.
But then since the answer's already up, I just hit plus 0.65, and my calculator says answer plus 0.65.
Gotcha. Yeah, gotcha.
And then it gives me the answer.
Okay, gotcha.
So the answer is 0.623.
Yes,
right.
That's what I got too.
Okay, I'm going to save it. Are we almost done? My head's starting to hurt.
Oh, I know. Was that it? Was that the last one?
No, there's one more.
Oh, there's one more.
Okay, so this one is the 80th percentile. So everything 80% and under, we need to shade.
See, I still did it backwards. So find.
But you know what? I just hit 80th percentile in my probability applet, and it shaded everything under it for me. I didn't even shade it.
It's 0.80, enter. So it is from the left red bar, everything to the right.
Yeah. So now are we taking, do the same thing and take the 0.07.
No, what do you mean by the left red bar, everything to the right?
Well, so what my z-score says is 0.842, and I have everything in the middle and everything to the right shaded is what mine shaded.
No, mine is the left.
Yeah, so the left side and the center should shade. Yes.
So the right is not shaded on mine.
Right.
Yeah. This test, so.
And honestly, like I said, I just plugged in 80 and it shaded it for me. I didn't shade anything.
Yeah, well, I wish it would do that, but it's not.
That's what it did for me too. And then did you get the z-score of 0.842?
Yes, 0.842. And then run that calculation again.
The same way we just did on the last problem.
Did it, right?
So hold on. So I just refreshed. I typed in 0.80 and it highlighted the left and the right and left the center blank.
Okay, so is your mouse maybe hovering in the middle or something? I don't know. But maybe just, since we're looking for the 80th percentile, that means everything from 80 and below needs to be shaded.
Okay, mine is totally not even working right now.
That's so weird. It has some kind of glitch, maybe.
Then 0.80 is what I'm putting in the area. I'm hitting enter and it goes to 0.
That's what it did for me a couple times. And I couldn't figure out, and I refreshed it and it still would go 0. So I don't know if there's some glitch in it or what.
Okay, well, I am done for right now. So does somebody want to just give me the Z-score that they got?
Yeah, 0.842.
0.842.
Mm-hmm.
Okay, now I just have to solve. So give me just a second. All right, I have an answer. Everybody else does.
Do you have
Are we supposed to round it?
70909? Did
Yeah, 0.70894.
Ooh, wow. Nope, that's not what I got.
I got 0.709.
0.709, right?
Oh, okay.
Yeah.
So it's 0.709.
Yes.
That is what I got.
Okay. So we ready to submit?
Oh, heck yes.
Oh, man.
Just ready to be done.
Done. Holy cow. Okay, so there's one we missed.
It's probably the one that we.
No, we did. Let's see. Yeah, it was that number 7.
It's supposed to be B.
It was probably supposed to be B.
Yep.
Okay, so we could just go through this on our own and resubmit this one, and we'll get our 100% on it.
Yeah, we got a 95. I'm not sure I really care.
I still have that. I actually, when I went to do this, I actually went and pulled up the homework quiz first. Wasn't even thinking, and so then I had to hurry up and get out of it. So I may not even have a homework quiz. Maybe it. Have you ever done that where you pulled up the wrong thing and then got out of it?
Oh, you know what?
Because it may be that my homework quiz is now null and void because I took it, even though I closed it really fast.
So I
don't know.
I would email her.
No, sometimes you can go back in and it'll say continue.
Yeah.
Yep. Then does the time continue to run? Because I don't want it to think that I looked up all of those and now I'm looking up the answers for like 3 hours. And then go
no, yeah, no, that doesn't matter. You can have your other quiz open. It's exactly the same, and just plug all the data in that you already figured out and fix the ones that were wrong. So just keep them open side by side.
Oh, okay. Yeah, well, I just want to make sure that that homework quiz.
Yes.
I don't know.
Yeah. No, you're good.
So have you guys done your homework for this lesson?
No, I halfway. I still need to finish up the homework.
Yeah. There's still lots of questions that I have on it, but.
Yes.
Okay, next Thursday, I may not be able to meet. So, my husband's still working out his schedule, but if he has the day off, then we are going to try to go down to the temple.
Oh, awesome.
It's a 3-hour drive just to get there. So we leave like at, 6 in the morning here.
3-hour drive. Yeah, that's long.
It's a long drive.
Yeah.
So do we want to try to meet on Monday and Wednesday? Does anybody feel like they're going to be ready by Monday?
I won't be ready by Monday.
I won't be ready by Monday, but I can do both days work on Monday, and we could meet on Wednesday. We could meet on Wednesday.
Well, let's go ahead and meet Tuesday and do the one, because I really thought that I was going to be ahead today, and after taking this quiz, I'm like, yeah, no, I'm not.
Yeah, this was trickier than I thought.
There's just so much information, and to have to weed out what's important and what's not.
Right.
And know what tool to use when. It really is. I have to go back every single question and look through. So.
Well, Christy, what time? I know you don't like doing homework and whatnot when your kids are around on Thursday. And I know you and Joy are like 1 and 2 hours ahead of Sherry and myself. Do we want to try to schedule a different time Thursday later on, like when you're back from the temple? Or should we see how Tuesday goes and see if anybody has the homework done and we can meet Tuesday and Wednesday?
We don't get back until, evening time. If we need to meet like later once my kids go to bed, or which
okay.
wouldn't be till like 7 o'clock your time, because like we do scripture study and whatever, but the test is due that night, and so if we have any
any glitches,
and the homework that night, and so I worry about that.
Yeah. Should we try for Tuesday and Wednesday this week then? This next week?
Let's try it. We'll see what happens. And if not, you'll have to.
If not, then you guys just meet, the three of you, on Thursday, and I'll find another group or meet with the TA or do something.
All right.
So.
Okay. We'll see if we can have it done. If not, I guess we can go through the homework. We can take a 2 or 3 hour meeting on Wednesday.
That's right.
Okay.
But I will try. And yesterday I thought, okay, I'm going to be able to meet Monday and Wednesday. And then after this morning, I'm like,
yeah, it takes too long to get through some of the other work first.
Yeah. So, okay.
All right.
Who's doing the hangout? Do you want to try the hangout,